Welcome to this channel. In this video, we are going to discuss one interesting problem from JEE Advanced Paper 2012. This is regarding one function, and function, its domain and its codomain is defined. Okay, and for this function, we need to find out whether the function is one-to-one or it is also on-to or not. Okay, so these are the choice. It could be 1-1 or on-to, or it could be on-to but not 1-1, 1-1 but not on-to. Okay, and neither 1-1 nor on-to. So these are the four choices given. Now we need to understand whether function is 1-1 or not, and again whether it is on-to or not. So these kind of problems are coming regularly in IIT papers. Okay, so don't be scared. You have to understand this concept well. I have made several videos on functions, so if required, you can go through all those things. In this video, again, I'll discuss these 2 points, whether when the function will be 1-1 and when the function will be on-to. For this particular problem, I'll be discussing in detail. Okay, so please understand this thing carefully. Listen to me what I am saying. Okay, now to discuss this thing, we need to understand what is the 1-1 function, right, or what is on-to. So these two concepts are important: 1-1 and on-to. What is the meaning of these two, right? So function, just 1 minute, function f of x. So x, from x, will get one function, will define one function, and function value is f of x. This will call it input, independent variable, and this f of x is dependent variable, and its value I'll call it output. Or sometimes it is also called image, right? For some value of x, we'll get this function value f of x. So these two things we need to understand. There should be a mapping between input and output, and that is your function here. Okay, now when this function will be 1-1 and when the function will be called as on-to, okay, that we need to understand. Okay, now this x, this input, so this in general we'll consider it's called domain. Domain is basically those interval of input so that the function is completely defined. This f of x is completely defined. That interval is called the domain of the function. So in this case, in the above case, you can notice that f, it is written as in this way. It is 0, 3, and then map to, this is map to 129. Okay, both the third bracket is used, means points are included, right? So this interval, it is we'll calling is the interval in the input, or I can say it is a domain. And this one, this is the image span, and that I'll call it codomain. So these two are given. The domain is given, the x is varying. So here x is varying within 0 to 3. And here the function value f of x, that will vary from 1 to 29. Right? So this is the main thing, the domain and codomain. Now here we need to understand basically how it is mapped. Okay, so this on-to and 1-1, these two things we need to discuss. For that, we need to understand what is the range of the function. Range is defined as the maximum value and minimum value, this minimum to f maximum, this interval within this domain, okay, if I choose the x value from the domain, then we will get certain values of the function f of x. Its maximum value and minimum value we can understand, we can find out. So this interval will be called as range. And if this range and this codomain, they are same. So if this range is exactly same as the entire codomain as it is given, codomain, then we'll call that the function is onto. What is the meaning? Meaning is that from this codomain, if I choose any one point, that point we can get from this input domain for certain value of input domain. Okay, so graphically we can show these things. So what I can do? So I will consider one set. This is one set, that is the input, span of the input, or it is the domain, and it is mapped to another space that is called output, or I could call it codomain. Right? So here lots of inputs are there, x values. Here these are the x values that we are considering one set here. Okay. Similarly, in the output there will be certain points, the values of f of x. So this is your x, this is your f of x. So one point, if I choose one point from input, and if I consider that point in the function, then function is mapped to another point. Suppose this is the point. So this point is the corresponding image of this input point x. Okay, this function is defined in this way. So I'll choose one point from the input x, then I'll evaluate this function value that will be in this output space. Okay. Now if for every input point, if I find, so this point is mapped to this point is mapped to this point, okay, like that. And if I choose all the points in the codomain, right, and for every point at least there is one input point, okay, at least one input point, if we find it, then that kind of a function is called onto. Means every point should be somehow linked to here and there. All are. Okay. All points will be mapped to from input space. Because we will find the image on this output side, all image points will find it from the input only. Then it is called onto. The meaning is that its range, it is also the range, because in this we will find all the image here. So exactly what we can do, we can show in this way. This is the codomain. Okay, this is your input, right? Now range could be subset. This could be the range sometime. Meaning is that all the points, if I consider from input, they will map to only within this range. Okay, all the things, not outside. Every one should be within this one. So this range, within this one will find all the inputs, but codomain may have some element here. This point is not mapped to any point on this input space. Okay, in that case the range will not cover entire codomain, so it is not onto. Okay, so in simple words, what is the meaning of onto? Onto meaning is that if range is exactly same as codomain, whatever it is specified, then it is called onto. If it is not true, then it is not onto. That simple thing. Okay. So we need to, so here in this problem, you can see that domain is given, domain is 0, 3, and codomain is also given 129, right? This is your 0, 3, this is your 129. Okay. So I need to find out the range. If range is again 1 to 29, then it is done, and I'll say that function is onto. Okay. Otherwise, if the range is less than that range, the codomain range, then function is not onto. Okay. Now let us understand what is 1 to 1. Okay. Next one is 1-1 mapping. So in this case, for 1-1, this input, this is the input space, this is the output space. So every input, one input is mapped to only one output, one image, and different input will have different image. Okay, so all are different, and again it will cover the entire output range. Okay, but I won't find anything that, okay, the same for same image, two inputs are there. Okay, it's like this. Suppose I have, this is one input and this is your output, but I have two input that is corresponding to one image, this image or this image. Okay, so these two value x1 and x2 both will produce the same value, means f of x1 is same as f of x2. In that case, it's a many to one mapping. Okay, this is many to one mapping. So for 1-to-1 mapping, only one input is mapped to only one image in the output side. Then it is called 1-to-1 mapping. So how to ensure these things? When I will get 1-to-1 mapping and when we will get many to one mapping for a continuous function f of x. If f of x is continuous function, then we need to understand which time we will get 1-to-1 mapping and which time we will get many to one mapping. Now my claim is that if function, if this is the x-axis, if I plot this function f of x, if function is growing continuously, okay, or function is decreasing continuously, okay, this is the x, this is your f of x. So you can see that if I consider one interval here, this is my domain, this is the domain. For that, so suppose at this point is x1, this is your x2. For x1, this is the corresponding image, the function value, and this is the corresponding image, function value. So you can see that within this one, if I choose any other points, every point will have separate image because it is continuously, it is increasing. Okay, so no two points will map to, will give you the same function value f of x. So if function is monotonically increasing, I will get obviously different function values for different input. Similarly here, so this to this, if function is reducing gradually, again this is the image, then this, for this point this is the image, for this point this is the image, for this point this is the image, for this one this is the image. So you can see if this is my domain, this will be the range, so this to this, okay, but within this range all the image will have a corresponding input, distinct input. Okay, so in simple manner I can say that if function is monotonically increasing or monotonically decreasing, then it is 1-to-1 mapping. Okay, but if function is like this, if function is, so sometimes it is increasing, sometimes it is decreasing. So if I consider this is my domain, this is our x1, it is x2, this interval, this is your domain. Now you can see the range will be up to this. This is the range. This is your f of x, right? So this is the maximum value and this is your minimum value within this interval. But you can find that some value, this one, for many times. For this x, I can have this magnitude. Again for this x, again I will have same magnitude f of x. Okay. So for more than one input, I can have the same function value f of x. So if sometimes it is increasing, sometimes it is decreasing. So in that case, it is not 1-to-1 mapping. Okay, I think it is clear. So for 1-to-1, the requirement is that functions should have monotonically increasing property or monotonically decreasing property within that interval. Okay, if sometimes it is increasing and decreasing, then it is not 1-1, right? So this is the concept. Now, how to solve this problem? The next question is that we want to solve this one. F of x equals to 2x cube minus 15 x square plus 36x plus 1. We need to understand when function will increase and when function will decrease. To understand function increasing or decreasing, first step is we need to compute derivative of this function f prime x or f dash x. This is a derivative df dx. Okay, so that I'll compute first. Okay, so what is this? It is a 2 into x cube. X cube derivative is 3x squared, so it will be 6 times x squared. Then it is x squared is 2x minus 30x, and this is your 36 into 1, and 1 derivative is 0. Okay, so here I can take 6 common, x squared minus 5x plus 6. So this I can have factors ax minus 2 and ax minus 3. Now you know that this derivative function, if it is positive, then function is increasing. F is increasing. Okay, and if it is less than 0, that time f is decreasing. And if it is equal to 0, that time I can say that f is having maxima or minima. Okay, so for maxima minima we can put f prime x equals to 0, then we can solve for x. There we can have the maxima or minima. Now to understand maxima minima and where it is function is growing or decreasing, we need to use sign convention. Okay, I need to understand the range when function is increasing, when function is decreasing. So this is your x. Now I'll consider this one. What is the solution of this one? Fx equals to 0, f prime x equals to 0. So this will be simply x equals to 2 and 3. Because if I put x equal to 2 here, it will become 0. If I put x equal to 3, this will become 0. Okay, so I have 2 points, 2 and another point is 3. So here I will take one vertical line. So same thing I have discussed in several videos. Please follow the several previous videos to understand this thing better. Okay, and now you can see that this derivative function, okay, if I choose any point which is more than 3, both the terms will be positive. Okay, x minus 3 is positive, x minus 2 is also positive. So their product is also positive. So if x is more than 3, both the terms will be positive. Thus, this region will be positive. So when x is more than 3, this total region, it is positive. Similarly, if I choose one point between 2 to 3, that time x minus 3 will be negative. This will be negative, but this will become positive because it is more than 2, it is positive. So it's 2.5. 2.5 minus 2 is positive, but 2.5 minus 3 is negative. So one positive, one negative, this product is negative. And this alternative, this is again positive. Okay, because both will be negative. So entire this zone. Okay, this is another zone. So I have got three region. One is from minus infinity to 2. That time derivative is positive. 2 to 3 derivative is negative. 3 to infinity derivative is again positive. So in this range function is increasing. So this is increasing. Here it is increasing because this is positive. Here it is decreasing. Okay, because it is negative. Here again it should be increasing function. Okay, so we understand when function will increase, when function will decrease. And now you see that this function is increasing from minus infinity to 2, then suddenly it is decreasing. Means at this point x equal to 2, I will have one maxima. And at this point function was decreasing, then again beyond 3 it is then start increasing. So here it should have minima. Okay, so these two values we can calculate. What is the maximum value, what is the minimum value, and then we can draw the function, total function. Then we can understand whether it is a maxima or minima. Now I'll draw it again neatly. So you can see that f prime x is given as, we have obtained as 6 times x minus 2 and x minus 3. And function f of x is written as 2x cube minus 15x square plus 36x plus 1. Now we need to draw the total function. Okay, this is your x, this is suppose 2, this is your 3, this is suppose 1. Okay, now this side is minus 1, minus 2, all are there, but this is not useful for us. From 0 to 3, because 0 to 3 this is the domain given. So these two days only. We will focus on this range, this interval. This is our input domain. Okay. Now, but we will try to draw the entire function. So we understand that at 2 it is having maxima. So I'll draw this line again. So this side 0 to minus, so minus infinity to 2, it is increasing function that we have seen, and 2 to 3 this is decreasing. Okay, and beyond 3 to infinity that is again increasing. Okay, and f of 2 is having maxima and f of 3 is having minima. Local, remember, this is a local minima, not entire minima, within that range. Okay, now what is f of 2 value? So I can put these things, x equal to 2. So what is f of 2? So 2 into 8 minus 15 into 4, and this is your 36 into 2 plus 1. So it is 16 minus 60 plus 72 plus 1. So if you compute this one, 73 plus 16, okay, so 73 into 16, it's 80, this one. So 3 is it's 9, it's 89, okay, and this is your minus 60. So value is 29. So maximum value is 29. Similarly, you will compute f of 3. If you compute f of 3, then what you will get? 2 into 27 minus 15 into, this is your 9, 3 square 9, plus 36 into 3, and it is plus 1. And that value if you compute, I think you will get 28. So this is, sorry, this is your 29 and this is your 28. Okay, f of 2 is 29 and f of 3 is 28. Now we understand, now what is the value at 0, starting point? f of 0. Can you find the value f of 0 again? That is very easy. This is 0 minus 0 plus 0. This is 1. So this is 1. So at 0 this value is 1. So this value is 1. At 2 value is 28. So this value is 28. Okay. 29. Okay. And at 3 it is having this thing 28. Okay. Now we understand that this range minus infinity to 2, it is increasing function. So I can draw one function, it is increasing. And you can also understand this thing that f of infinity, the function is going towards infinity. And f of minus infinity, if I put it, so this, because of this one, minus infinity, it will become, this is dominating 1. I can ignore all the things. So it will become minus infinity. So meaning is that toward the minus infinity side, it will become minus infinity. So I can have this kind of plot. Here it is continuously increasing, and it will increase till this point. Okay, and then it will decrease up to this, and then function is again increasing, going towards infinity. So this is the shape, rough shape. So this is this side is going, okay, of this function f of x. So what is the maximum value? F max within this interval is 29. What is the f min? Remember, within this, so this is f minimum local 1. This is decreasing up to minus 28. But this is your range, because it was from 0 to 3, it will start from 1. So minimum here I will consider is 1. Thus range, so range will be 1 to 29. Okay, that is same as this thing given, that is again the codomain. Okay, so what is the meaning? Range is equals to codomain, so it is on 2. Okay, it is sure that function is on 2. Now here again you will see that this function is increasing sometimes 0 to 2, and 2 to 3 it is decreasing. So for certain values for x, okay, we will have two values of x, we will have the same magnitude. Suppose here, suppose 28.5, this value, I can have two inputs. So this will give you 28, again this will give you 28. So it is many to 1, so not 1 1. Okay, because sometimes it is 0 to it is increasing, then 2 to 3 it is decreasing. So what is the meaning? So two things I have got. The function is on 2 but not 1 1. So which one is correct? So function is on 2 but not 1 1. Okay, so option B is correct. I hope this part is clear to all of you. If you have any confusion, please let me know in the comment section. You need to understand this thing well, because at least one problem you will get from the function, even in the advanced problem or the main paper. So don't skip this part. Try to understand this portion well so that you can solve any problem. I have solved several problems in my channel. If you have any doubt, please let me know. I'll make more videos on this topic. I hope you will get the idea and you will be able to solve it. Okay, so thanks for watching. I'll make more videos, and if you have not subscribed the channel, you may subscribe the channel if you want to get this kind of videos. So thanks for watching.